Greetings to you in the mighty name of our Lord Jesus Christ. I am called Gamboripa Christopher, and I'm going to be your instructor throughout this session. On this slide is my email address and phone number. For any official communication, please use this email to communicate to me. You can as well use my WhatsApp number for either WhatsApp or direct call. I use it for both. Without wasting a lot of time, let's get into the overview or objectives that we are to achieve in this course unit. First of all, one of the objectives we need to achieve is to identify the various parts of a computer system and what each does. Identify the various operating systems. Identify major software application packages and what they do. Know how to use common features of Windows and the desktop. Know how to organize files and folders using Windows Explorer. Be familiar with features common to Windows software. Have a working knowledge of Microsoft Office software. Uses of computers in the business, workplace, and other fields. Explain why information systems are so important today and how they are transforming organizations and management. These are some of the areas we are going to look at as far as this course unit is concerned. Let's start by defining what you would call a computer. By definition, a computer is an electronic device that inputs data, processes the data, which is the same as converting it into information that is useful to people, outputs, and then stores the information, which is very, very true. Computers are controlled by programmed instructions that transform the data into meaningful information. Generally, a computer is a device that accepts input, processes it, stores the data, and then produces output, which is very, very true as well. But when we look at these various definitions, let's start by the very first definition. You're going to realize there are key terms that we need to understand in this definition, because it's what this determines for us to call something a computer or not a computer. Let's start with the very first, which is electronic device. Before even we look at the word device combining, because these are different words combined, what do we mean by electronic? Electronic is anything that uses electricity, has its source of energy, which uses electricity for energy. And we know very well computer uses electricity as energy, which is true. Why do we call it a device? What does the term device refer to? Device is any hardware component of a computer. Any hardware component that you can see and touch of a computer is known as a device. That's the term that is given to it. If it was in the terms of electricians, they would have said electrical appliances. But for us in IT, we also have our own language. We call it electronic device or devices. We also have what you call input. What is input? The process of feeding data into the computer is known as input or inputting. Then we come across another term which is known as data. What is data? Data is just a collection of raw facts that we give the computer. Then we have what we call processing. What is processing? Converting the data into information. that is useful to people. Then we have output. What is output? The feedback that we get out of the computer after giving it the data, and then the data has been processed. The feedback that we get is termed as output. Then how about storage? Of course, after feeding the data into the computer and it has been processed into information, we should be able to store that information. That is what we term as storage. And there are devices that are responsible for all these different stages or these different key terms that we have talked about in our definition. If you want to take it to a higher note, you're going to realize still why do we call it an electronic device. We know very well computers operate in a binary base. And when we look at the rules of bases, obviously we know binary base is base 2. And we know under the rules of bases, you cannot have a number equivalent to the base or greater than the base within the same base. What do I mean? If we are saying we are operating in base 2, it means we cannot have 2, 3, 4, 5 in the base of 2. We can only have 0 and 1. And when you take that to the computer, basically, computer interprets everything given to it in terms of zeros and ones. And if you take this to a higher note, you're going to realize the zeros represent no electric current or no current, whereas the 1 represents a current, a flow of current. That's why on most of your electronic devices, you're going to see on your button, there's a symbol of a 0 and a 1. In most cases, people don't understand this. But there's a symbol of a 0 and 1. Let's try to look at it on this slide. Computer power button, computer. Button symbol. Let's try to look at this if they can give us some images about what I'm talking about. Yes, this is what I'm talking about. This is actually a 0 and a 1, meaning that you can use this same button to power on the device, which is the 1, which is representing electricity is on. You can use the same button to power it off, which is a 0, meaning electricity is off. That is what this symbol represents. This is a 0 and a 1. And that is how a computer operates. And when we come to our binary base here to try to understand very well what I'm talking about, you're going to realize, let's say we have a word like Chris. So we have text to binary. Chris. This is what a computer understands when you type the word Chris. The letter C alone, this is what the computer understands. 0, 1, 1, 0, 0, 0, 1, 1. That is letter C in machine language or in computer language. Obviously, if the computer was operating in this, giving us this, has Chris, very few people will be interacting with the computer, because you wouldn't, if I didn't tell you this word here or these figures here represent the name Chris in computing, you wouldn't actually understand. It means that you would not have much of interaction with the computer, only people with special skills. But computer is able to do this and convert it. It first of all picks what you're giving it, understand it in its own language, which is the binary base, which is essentially zeros and 1, and I've told you the zeros and 1 represents 0 represent no electric current, whereas 1 represent electric current. So it takes whatever you've given it, understand it in that term, then interpret it, which is the same as converting it back to what you understand, and you're able to see the word Chris printed on your screen in just a split of seconds, meaning the same time you're typing is the same time it's processing and giving you feedback at the same time. So that is one thing that we need to understand about computers. It's very fast in its operations. When we come here, we're going to see what we call information processing cycle, which still comes from our definition up there. And this is what we use to put any device into test if it qualifies to be a computing device, if it qualifies to be a computer or not. Because in most cases, a layman knows that a computer is either a desktop or a laptop. But we have computers in almost everything, or most of the things around us nowadays. And for us to actually determine if it's a computer or not a computer, we need to look at, to put it to test based on our definition, whereby we ask ourselves, is it an electronic device? Is it electronic? Does it use electricity for its work? Yes. Does it accept input? Yes. Does it process the input? Yes. Does it give output? Yes. Does it store the result? Yes. Anything that actually meets all this, the standard according to this definition, is a computer. And at this point, I always ask students, when you look at the scientific calculator, not just any calculator, the scientific calculator, I'm going to leave you with this question: do you think it's a computer or not? We shall have this discussion in the forum. Okay, let's proceed. Information processing cycle. Steps followed to process data. We have input, we have processing, we have output, and then we have storage. What is input? The data provided to the computer by a person, the environment, or another computer. Data that is provided to the computer is known as input. And the things that we use to input this data into the computer are known as input devices. And examples of input that we can look at, we have words and symbols, we have numbers, we have pictures, we have audio signals from microphones, we have signals from other computing devices, we have temperature, speed and pressure, etc. sensors. These are all examples of input. But we have what we call input devices, which are devices that we use to feed the information, the data rather, into the computer. Why don't we say feeding information to the computer? Because at the input stage, we are not dealing with information, we are dealing with what you'll call data. And examples, what are some of the examples that can come to your mind when you think of this? Think about them, we proceed, we shall be able to look at them as we advance, or we shall have them in our discussions in the forum. But keep this question in mind: what are some of the examples of input devices that comes to your mind? We also have what you call processing. The processor is responsible for the manipulation of the data within the computer. The processor is actually termed as the brain of the computer. Data are symbols that represent raw facts, objects, and ideas about people, places, events, and things that are important in an organization. In other words, data is just a collection of raw facts that has to be processed by the processor. A computer program or software is a set of instructions that tells the computer how to carry out processing. Much as we say the processor is the brain of the computer and is the one responsible for the processing, we also need the sets of instructions that will control the processing process. That is now getting complicated. Processing process, or the processing activities rather, if to make it simpler. We have examples of processings. We have arithmetic calculations, we have sorting a list, we have modifying pictures, we have drawing graphs. Arithmetic calculations are all the calculations that are done within your computer. We have sorting a list. Of course, you can organize, let's say in Microsoft Excel, you can go there and then enter the students' grades, and then you can sort it from number 1 to number last, that is ascending to descending or descending to ascending, depending on your requirement. Modifying pictures, that is image manipulation. We know this very well. At least the Gen Zs, you understand this so much that you can see someone's profile on social medias, you see the pictures they post, and you see a real person. They are two different beings. You see someone fair skinned, very brown or very light, or not having any rashes, looking no pimple, no nothing. But when you see them in the real life, they are totally different. They get the pictures, modify them. After modifying them, they post them. So picture modification, this is a topic we understand very well when it comes to the Gen Zs. Then drawing graphs. These are some of the examples of the processings that takes place in the computer. Then we also have what you will call output. The result produced by the computer after processing the data is known as output. Then we also have output devices. The display units such as the monitors. We have prints whereby it can be printed on a paper by a printer. Then we have transmit the results after processing. The output devices displays or prints or even transmits the results after processing. Examples of output: we have images on a monitor, we have printed documents, we have sound, we have signals to device controllers. Here as well, just like the input stage, we also have output devices. These are devices that are used to output the information from the computer. Remember, at the output stage, we are dealing with information. And at the input stage, we are dealing with what you'll call data. So, just like the input stage, I want you to keep this question in mind. We are going to have it in our forum, and we shall still look at it as we advance in our notes. What are some of the examples of output devices that comes to your mind? Then we have the last part, which was talking about storage. Of course, at this point, we are going to look at the memory and then the storage. Memory is the area of a computer that temporarily holds the data that is being processed or waiting to be processed or stored. Waiting to be processed, stored, or output. Yes, when you're looking at the memory, this is just a temporary storage, meaning that it can only hold the data for as long as there is power on the computer. And the example of this is what we'll call RAM which stands for random access memory, which holds the data for as long as there's power on the computer. Once you power off the computer, it loses that data. Why is it important? Remember, as we were talking about the processor up there, we said it's very fast in its operation. For that very reason, it also needs a place where it can be getting the information at a high speed. RAM being faster than the normal storage in its operation, it is the ideal location for the processor to be collecting its data from. So that is the reason why we have the RAM in place. And random, as we advance, we're going to see the why we have it random, calling it random or random access memory. It's because any portion of the RAM can be accessed at any given period of time. Then we have the storage. This is where the information rather, can be left on a permanent basis. We know very well if you were typing in Microsoft Word on your computer and then your computer goes off, you're going to lose that if you didn't save that data that you were typing. If you didn't save it, because by the time you were typing, or when you open and you were typing, it was running on the RAM or on the memory. When you power on your computer, the sets of instructions on your operating systems are loaded actually on the memory, which is known as the RAM. Without the RAM or the memory in your computer can't operate. Now, don't get me wrong. You're going to open your computer and then you check there's no RAM, and then your computer is working and you're like, the teacher lied to us. How comes my computer works without the RAM? There are some computers whereby the RAM chip is embedded on the board. You have two provisions. You have one which is embedded on the board of your computer, and then you have an extension slot where you can put another RAM. I've seen computers like that. Meaning that if you remove the extension, you still have RAM on your board. It will still work. But these are rare cases. Most of the computers are just having the RAM slots where you can either insert or remove the RAM. And then you have cases whereby there's no extension slot. Your RAM is just embedded on your board. You can't remove it. Bottom line is, your computer needs the RAM for its operation. Without the RAM, the computer can't operate. Then we have where we store the information that has been processed, the data that has been processed for permanent basis, which is now the storage. And examples of the storage, we have the magnetic disk, we have the CD-ROMs, we have the magnetic tapes, we have the floppy disks, and then we have the memory cards and so on and so forth, flash disk and so on and so forth. The beauty of these things is most of the things we're talking about in this class, we are actually going to have a session where we have to look at them physically. So this is where this session ends, and let's meet in the next session. Thank you.